So this is the 2021 question 6 organic chemistry question. So we're going to focus today on part D, which is the thermochemistry calculation. In this part you're asked the heat of combustion of ethane thiol and mercaptan according to the following balanced equation is minus 1867.5 kilojoules per mole. So that's an exothermic reaction. We're asked to use this heat of reaction and the heats of formation of CO2, water and sulfur dioxide respectively to calculate the heat of formation of ethane thiol. So what's our target here? Okay, so we're asked to calculate the heat of formation of ethane thiol. So let's write out that equation, okay? So the target equation here we're looking for is we want to make the heat of formation of ethane thiol. So we're making 1 mole of ethane thiol, okay, from its elements in their standard states. So ethane thiol has the chemical formula C2H5SH. To make 1 mole of it, I'd need 2 carbon atoms, 3 molecules of hydrogen and 1 sulfur atom. So this is my target. I want to work out the heat change when this reaction happens. So I'm going to use the information given in the question. The first thing that I was given in the question is I'm given the heat of combustion of ethane thiol. So I'm going to write that out here now as reaction 1, okay? So this is going to be chemical reaction 1, and I have the delta H, the heat change over here that I was given in the question. We're also given the heats of formation of CO2, water and sulfur dioxide. So I'm going to write out those equations in full. So the heat of formation of CO2 is where I make 1 mole of CO2 from its elements in their standard states. Okay, so carbon and oxygen, O2, give me CO2. And my delta H there is minus 393.5 given to me in the question. I do a similar thing for the heat of formation of water, heat of formation of SO2. To make water, it's 1 molecule of hydrogen, half a molecule of oxygen. Okay, and to make 1 mole of SO2, it's 1 sulfur atom and 1 molecule of oxygen. Okay, so these are my given equations, and I'm going to use those now to construct my target equation. Okay, so let's work systematically through this equation and build it using the 4 given equations I have here. Okay, so let's construct our target. So I'm going to need 2 carbon atoms. So that would mean that I could take 2 times equation 2. So equation 2 times 2 would give me 2 carbons and 2 O2, giving me 2 CO2. And I would have 2 times the delta H for that reaction, minus 393.5, which would give me overall minus 787 kilojoules per mole. Okay. Now, to have 3 molecules of H2, I'm going to take reaction 3. I'm going to multiply that by 3. So that will give me 3H2 and 3 over 2 O2, giving me 3 waters. And when I multiply my minus 285.8 by 3, I will get minus 857.4. Okay. Now, to get 1 sulfur atom here, I'm going to take equation 4 here and just multiply that by 1. So just take that equation as it is. Okay, so that's just going to give me 1 time minus 296.8. So that's minus 296.8. Okay, let's go over to the other side of my target calculation. So I want to have 1 mole of ethane thiol, but it's on the product side. So the only equation that I have in which this molecule features is my first one, but it's on the wrong side of the equation. So what I do is I take this equation and I flip it around, which means taking equation 1 and multiplying it by minus 1. Okay, so I'm multiplying it by minus 1, so I'm flipping it around. Okay, so that means my reactants become products and my products become reactants. Okay, so let's just do that now. Okay, so minus 1, so I'd have 2 CO2 and 3 H2O and SO2, giving me C2H5SH and 4.5 O2. Okay, And then what I'm doing, remember, is I'm reversing, I'm multiplying the delta H of that reaction by -1. So minus by -1867.5 obviously gives me a plus overall. Okay. Alright, so let's just draw a line under all of that and see have we done enough to construct our target equation. Okay, so a lot of things are going to cancel here. Okay, so let's see. Okay, so my 2 carbon dioxides here cancel with these 2 carbon dioxides. My 3 waters cancel with the 3 waters there. My SO2s cancel. And look at my oxygens. If I add 2 oxygens, 1.5 oxygens, and another 1 oxygen, that'll give me 4.5 oxygens, so they all cancel. And what am I left with? Okay, I'm left with 2 carbon and 3 H2 and sulfur, giving me C2H5SH. And when I look back, that absolutely matches my target. Okay, so that's what I was looking for. Okay, so what I just do then is I add up all of my values here, and when I do that I get minus 73.7 kilojoules per mole, and that is the delta H for my reaction. So I've figured out my delta H, the heat change or the heat of formation of 1 mole of ethane thiol. So to make 1 mole of ethane thiol, it's an exothermic reaction, so 73.7 kilojoules of energy, heat energy, are going to be released. Okay, so let's now look at an alternative method to do this calculation. So yet again, our target here is to figure out the heat of formation of ethane thiol. So, and remember, we're given this equation in the question. This is the heat of combustion of ethane thiol. Okay, so we're given that, and we want to work out the heat of formation of ethane thiol. Okay, so according to Hess's law, the delta H for this overall reaction can be broken down into the sum of the heat of the formation of the products minus the sum of all of the heat of formation of all of the reactants. Okay, so what does that mean? That means that this delta H for this reaction is equal to the heat of formation of 2 moles of CO2 and 3 moles of water and 1 mole of SO2 minus the heat of formation of ethane thiol, okay, and the heat of formation of oxygen, which is actually 0. So remember, the heat of formation of any element, okay, O2 is an element, is just 0, okay. So let's write out that formula, okay, so that the overall heat change in a reaction can be expressed as the sum of all of the heats of formation of the products minus the sum of all of the heat of formation of the reactants. So let's go through that calculation now. So the overall heat change for this reaction was given in the question, okay, so that's the value there, okay. So that can be equated to now the sum of all of the heats of formation of the products. Okay, so the products here we have 2 CO2. So 2 times the heat of formation of 1 mole of CO2 was given to us in the question as minus 393.5 kilojoules per mole. And we have 3 water. Okay, so that's 3 times minus 285.8. And we had 1 time SO2. SO2 has a heat of formation of minus 296.8. Okay, so that's the heat of formation of all of my products. If I take away the heat of formation of my reactant, so in this question it's just the ethane thiol, and that's what we're looking for. So that's my question mark. Remember, the aim of the game here is to find the heat of formation of ethane thiol, okay? And I would be adding the heat of formation of oxygen, which we just said a moment ago is 0, okay? So what we have here now is that the overall heat change minus 1867.5 is going to be equal to, so the heat change of the formation of the products, when I work all of this out, so 2 times minus 393.5 and so on, I number crunch that and I get minus 1941.2 kilojoules per mole, and I'm taking away my heat of formation of my reactants, and for us that's my question mark, the heat of formation of my ethane thiol. Okay, so to get my question mark on its own, I just do a little bit of algebra. Okay, so let's bring that over because that's a negative at the moment. So the heat of formation of my ethane thiol is going to be minus 1941.2. Okay, bringing over my my minus 1867 becomes a plus 1867.5 kilojoules per mole. When I work that out, I get minus 73.7, putting in my units kilojoules per mole. Okay, so the heat of formation of ethane thiol is minus 73.7 kilojoules per mole. This is the method using Hess's law, and we previously saw the method where you construct all of the equations and cancel them out to work out the heat of formation.